Alright, so welcome back again. My name is Jesse, and in this wonderful and exciting tutorial, we're trying to see how to do named entity recognition of clinical and biomedical tests. So this is a format of Clinical NLP. So in this tutorial, we're trying to see and explore some libraries that we can use to do Clinical NLP, right? Specifically named entity recognition. So one of them is SciSpacy, right, which is very powerful for doing Clinical NLP as well as biomedical NLP. We also have Med7. So Med7 and SciSpacy all are libraries that depends upon Spacy, right? So they are pre-trained model that you can use together with Spacy. Spark NLU is built on top of Spark, which is very, very powerful by Just No Labs, and it's having a clinical version which you require a license or an activation key to work with, right? Because it's software you must buy, right? It's very, very powerful. It has some very cool features, and I understand the reason why you need to buy for this, but it's very useful, very powerful. And there's also CTEX and NRS. So let's see how to use SciSpacy MS7. Then another tutorial we'll see how to use Spark NLU, the clinical version. So I'm going to load my EDA packages and then my plotting library. Then we'll be loading our dataset. So the dataset we are using is a medical dataset from here, which consists of several medical history, an analysis MOBI and an analysis VT, together with the disease and a description. So I'm going to load that dataset. So let's load the dataset. The df pd read underscore csv my medical data set.csv. So let's open this and then let's explore this particular dataset. It's going to load the dataset and now we can explore it. So let's check it out. So if I go with df.head, we can see that this dataset has several tools, several features. So we have the label, right, which have several classifications. You can use it maybe in the future to do some test classification. We also have the description of the particular diagnosis, and we have the test, which is the medical history. So we'll be picking this particular one to extract clinical named entities from it. Okay, so let's see a simple example. So I'm just going to pick one. So df.ilog, and now let's pick 2, right? Then if I pick the test column, you can see what we have. So based on this simple data that we have several things there, right? You have the history of present illness and amnesis, right? And then we have the BMI, we have some information there. So we want to be able to extract if there are medical or there are biomedical named entities within them, right? So that is one of this. If I go back and I pick one like this, you can also see a different one, right? With different things that we can pick from. Okay, so let's see how to work with it. So we'll be using SciSpacy, then later I'll use Med7. So first of all, in case you don't have SciSpacy, you will have to install it. And then SciSpacy depends on Spacy, so you have to first of all install Spacy. So pip install Spacy to install SciSpacy. As the first thing, you need Spacy. And then after that, we also need to be installing SciSpacy, right? So SciSpacy gives you several pre-trained models that you'll be using. So we're using the CDR, which is a chemical disease relation model. You can get all the various models from here. So SciSpacy, right? allenai.github.io, SciSpacy, and you have several pre-trained models there, right? So different models there. So you need to install it. This is how to install it, and then you pick the model, then you install it. So I'll just come back. Sorry for it being small. Perfect. So these are the different models trained on different data. So I'll be picking the BC5 Biocreative CDR chemical disease relation medium database. So I just click on this and copy link address, right? So I go back again, then let's install it. So to install it, it's just very simple. So just go with pip install SciSpacy, right? Then pip install, I paste in the URL I copied, right? If I paste in the URL, you can see that it's the same URL that we have, right? And this is the particular model we'll be using. This is the name of the model, right? So this is what you use. So let's install it on our system. So I click on it to install it. So requirement already satisfied because I've already installed it before. It's collecting it from here. So this is going to be the pre-trained model, right? So there are several models you can use to do your work, right? Based on your test. Okay, perfect. Now let's go back and let's see some things you can do. So first of all, let's import the packages. So we'll be loading the packages. So we'll be importing Spacy, and then you also import Spacy and then also import SciSpacy. So import SciSpacy. Right, these are the two that have been imported. So let me import these two. Perfect. And now let's create our NLP object and then see how to do clinical NLP or clinical named entity recognition on our dataset. So to work with it, just go with, let's create our NLP object. So this is going to be my Sci NLP, which is going to be my Spacy.load, and I'll pass in the name of the model. Right, so this is the name of the model, which is the same name we had here. Right, this name, that's what I'm picking. So this particular name is what we are picking as this. Right, it's the same thing we have here. Making sure they're the same. Perfect. Now this is going to create an NLP object with the pre-trained model, not the normal default English that we use, but with this particular pre-trained model. Then let's explore the various components of this model. So this is going to be the component of the NLP object that we have. So to do that, we have two ways. We can just go with NLP dot component names, right, which is a class attribute. So now we can see all the various components. So we have the tokenizer. Let's make it smaller. We have the tokenizer, right? We have the tagger, we have the attribute, ruler, lemmatizer, parser, and then the NER. This is the most important thing for our test now, right? Okay, so let's first of all, in case I also want to see all the various entities for this one, I can also come back again. So let's explore the entities. So entities. So the entities, there is going to be my Sci NLP dot get pipe. Right, and then we are going to be picking this NER. That's what you're picking. So NER. So get pipe NER, and now I can just go with dot the labels, right? I go with this, it's going to list the various entities within them. So we only have two, right? Chemical and disease, because the model is what? BCDR, chemical and disease relation. So that's what you're trying to be picking. So it will only detect chemicals, which is drugs, and disease. In case you want more, you can use a Spark NLU, or you can use a different pre-trained model. So let's use it on our test, right? So I'm using on our test. So we have a simple test. So let's go to example 1, then df.ilog. Let's pick example, say 1 test, right? So just picking one of them. We're going to be able to see whether we'll be able to detect some tests from it, some disease from this. Perfect. So let's check this one out. So if I go back and I check it out, you can see you have some data there. Right, so these are all the data tests. So we're going to see whether we'll be able to pick all the named entities there, right? All the clinical terms within them. So it's very simple, just as we do always. So create our doc. So docs. Go to my Sci NLP, and I'll pass in my X. Right. If I go with this option now, we are going to have our object created, and now we can get the various stuff there. So there are a lot of things you can do. So you can actually explore and get all the entities within them. So first of all, let's extract all the entities. So extract all entities. So we can just go with this. So for entity in my doc.ents, right, I want you to print all the, see what I did, print all the entity dot their test, and then the entity dot their label. Don't forget the underscore. So the underscore means that get the string representation of it, not just the ring. And you can see that has been able to fetch all the diseases within our test, right? So snoring is a disease. It was able to identify that even knee pain, although it is separated, right? There's knee and there's pain. It's able to identify that this entire stuff here is a disease, right? Very cool. It was able to also identify some chemicals, cholesterol. Perfect. Even CVA, right? So this looks at an abbreviation, COPD, chronic obstructive pulmonary disease, right? It was able to still identify them. Very cool, right? Wow. Emphysema, diabetes, apnea. Wow. So all of these things, to be able to identify all of them as disease, even including weight loss, right? That means it's very good. Weight loss is not a disease. It can be it's a sign, but here we will still keep it under disease. Okay, so let's see how to work on it, right? So let's see how to visualize it. So in case I want to visualize the entire stuff to make it easy, we just use SciSpacy. So from Spacy, import this SciSpacy, right? And then you'll be using this Spacy to visualize the entire stuff. So I may change the theme to make it easy for everybody to check. So this Spacy.render, I'll pass in my docs, then I'll pass in the style that I want, which is going to be ents, and then let's specify that we want to plot it inside Jupyter, right? So Jupyter is equal to true. So let's run it. If I run it now, we're going to see the entire entities there, right? Very cool. It was able to identify all the disease within them. So we have he was difficult working, he has difficulty working 2 blocks of 5, difficulty with snoring. Wow. So all of them, it has been able to identify them, including some of the diseases. It was not able to identify penicillin, maybe because of the spelling and because of the abbreviation, but it was able to identify many of the diseases within them, right? Together with some drugs, some chemicals, right? So let's see. Perfect. So that is one of the very cool stuff you can do. Of course, there are a lot of things you can do with it. You can also do for the dependency pattern and the rest, right? But that is something very cool. Based on this model, you only have disease and chemicals, but you can work with other models and get more from that. Perfect. So let's try another package, which is going to be Med7. So the same way, this time Med7 depends upon Spacy 2.35. So to work, we just go with pip install Spacy 2.35, and then we are using Med7, which is found on huggingface.com, right? So this is going to be the URL. Don't worry about it. It's going to be inside the notebook, so I can also check it out. And then we'll be using Med7 to also do the same thing we did above, right? Now, whilst it is installing, let's see what to do. So it is still installing them. It's going to tell me to restart the entire stuff. So we will restart it. But before we work on this, we can also create some functions to extract all the disease from our data set, right? So let's see how to do that. So it's going to be very simple. So this is going to be a function to extract disease. So extract all the disease. So it's going to be a very simple function, and we create another function to plot them. So the function is going to be extract diseases, right? And I'm going to pass in my test that I want to extract from. Then this is going to be my results, right? So first of all, let's create a docs, which in this case is going to be my SciNLP. I'll pass in my test. Perfect. Then we're going to get the result. Then you're going to say that, okay, entity.test, let's use a list comprehension. So entity.test, right? Then see for entity in docs.ents, just as we did above, if the entity label is equal to disease, right? If it's equal to disease, I want you to pick that one out. So this is going to get the results. So let's return the results. So this is a simple function we can use to extract all the entities. So in case I want to extract all the entities, we will do that before we run the Med7, so we don't lose what we have done. Then I can just go back again. It's going to take some time, right? So I can just pick my data set. So let's go to diseases. Then df, I'll pick the test column dot apply, then lambda x, extract all the diseases from our test. So this is going to extract all the diseases from our test. It's going to take some time for it to run because it's a lot of diseases, and as you can see, this is going to be changing because it's going to be spending more information. So whilst it's doing that, let's just create another function to plot them. So I'm going to create a function. So function to plot the diseases, right? To plot the commonest diseases. So this is going to be using word cloud. So we're going to be importing word cloud. So in case you don't have word cloud installed, you can just install it. Just so pip install word cloud, right? That is how to install this. So let me copy this one and paste it above. So while this one is running, we will be working on the word cloud aspect. We create a function for it so that it becomes easy for us. So in case you have any question or contribution, you can put inside the comment section below. So let's go back again to this and let's plot it. So it's going to be very simple here. So let's call it as my def plot word cloud. Then this is going to take in my value, so let's call it as my test that I want to pass in. Then this is going to be my word cloud. So it's going to take my word cloud, so I have to import it. So it's going to be from word cloud, import word cloud, and then I'll pass in my word cloud here. I pass my word cloud, so word cloud, the word cloud class. Yeah, so word cloud dot generate, and then I pass in my test, right? So now we can just plot it. So plt dot imp show, this coming from matplotlib. I'm going to pass in my word cloud, right? And then interpolate, interpolation, let's set that one to bilinear. You can change it as you wish. Then you can now set the others off, and then we can now show it. So this is a simple function that we have created to help us plot our disease, right? The most common disease for a particular test. So while this one is working, we will just fetch all the diseases. So based on the data set we had, right, we have different labels. So we have 3 different labels. So df dot labels dot unique. If I go with this option, you can see that we have different labels there, right? We'll take some time for each one. Perfect. So at long last, that's finished, right? It has finished with all of them. So let's go back and check it out. So df head, and now it has finished them, right? So we can see that it has been able to extract all the diseases from our test, right? Perfect. So we want to get all the diseases per the labels and then plot them. So how do we do that? So first of all, let's go back again, and then let's see how to do that. So I'll just come back to the top of my file, and I'm going to create a simple function. So in case I want to get all the diseases per label, so we have the label, which in this case we have 3 different labels. So I want to get the label like, say, surgery, right? In case I want to get this one, I can just go back again. So this is going to give me all the diseases that are called label. So disease, or diseases, yeah, I think so. So if I run it like this now, it's going to fetch all the columns. Yeah, because I think I made a mistake. It's supposed to be diseases, right? It's going to fetch all the columns that have the label surgery, and it's going to give us all the diseases, right? So some of them it's missed because they are not, it was not able to find anything. And now I can convert this entire stuff to list. If I convert this entire stuff to list, it's going to convert the entire stuff into a list format for us, so we can use it for our plot. But in converting it to a list, you can see that it is still a list of a list, right? So we want to take out all of these things, so we have to just look through it. So let me show you how to do that. So I've written a simple code to make it easy for us, because to save us time. And this is how it goes. So this is a simple function. So the same thing that we have gotten, right? We are going to pick the particular label, then we're going to convert it to a list as we saw earlier on, and then we're going to look through it to get it as one liner, right? As one list instead of a list of a list. So we're doing the same thing for all of them. So for surgery, medicine, medical records, and then for all the others. Perfect. And now we can plot it with word cloud. So we want to plot it and see which of these things are so, right? So I can now install word cloud, and now we can just plot them out, right? So we can actually set this size, but let's not do that now. So let's plot it. So in case I want to plot it, as you can see, there are 3 different labels. That's why I brought this one here, just to check the labels. There are 3 different labels. We have this label. I don't know why today I'm making a little mistakes with the typo. Okay, apologies for that. Perfect. So we have other internal medicine, surgery, and medical records. So now I want to plot for only surgery or for medical records. So I can just go with plot word cloud. Now pass in the surgery, right? I'll pass in the surgery diseases. If I pass in surgery disease, it's going to plot all the diseases that are surgery for us. So another error. So the expected string, right? Or by string, but it's got a list, right? Because it's a list. So what I'm going to do is I'm just going to go back again and convert the entire stuff into a list. So back. So there's a very nice library called Pretty Arrows that makes it easy for you to be able to see errors, right, in a very nice way. Maybe another tutorial will check on it. So dot join. So this is going to join the entire stuff as a document for us as one. Then now if I click on it, I can now plot it. So surgery, the most important thing for surgery, as you can see, is bleeding. There is blood loss, tumor for and then fracture. So these are the most commonest stuff there. You can also do the same thing for the other ones. So let me make it bigger. It looks like it is too small for me. Or you can make it bigger as you wish. Right, let's do another one. So this is going to be what I had here. So in case you have any question or contribution, you can put inside the comment section below. So this is going to be let's go with medical, because there's medical or medicine, there's medicine, records, and then other. So let's go with medicine, and then we just go with the other. Medicine, disease. So in the medical field, you have, when you are grouping patients, you can just group them according to surgery, if it's a surgical case, a medical case, or medicine case, that is internal medicine, and then the others, right? So it's like for medicine cases or internal medicine cases, we have chest pain, very common. We have shortness of breath. We have hypertension, abdominal pain. Nausea. These are the most commonest cases within or disease within our data sets, right? Very nice. You can also try the same thing for the next one, which is in this case is going to be for the other. Let's go for the other. So go with the other. You can now get everything out. So these are the other ones. These are the miscellaneous. Pain, right? Very nice. So now we have seen how to be able to extract entities from a clinical medical test using SciSpacy, and you have seen how to do some simple word cloud plot. You can make these ones bigger so that you can see it in case you want. I can just make it bigger. So this is going to be plt.figure. In case I want to make it bigger, then figure size 2010, right? So that now it is big enough. So if I go back again and I run it, this is going to be bigger so that I can see it well. Perfect, right? So this is big. Wow. Now you can see the disease. You have bleeding, stenosis, transverse carpal. Wow, very inguinal hernia. Hernia is also it's a very common surgical disease. Herniation, yeah, inguinal hernia and hernia. Abdominal hernia, umbilical hernia. Okay, so we see that this is also very cool, right? Just some very nice stuff. Let's try the last one so that I can see it bigger. So to finish with it, let's end it with the final work, which is going to be my Med 7, right? So we're using Med 7 to help us with that. So first of all, we have already installed Med 7, and to work with Med 7 you have to restart the runtime. So let's restart the runtime again. You are going to lose most of the variables, but the notebook will be available so that you can use it. Perfect. So it's restarting the runtime, as you can see, and now let's load the dataset and then let's check on it. So that's finished. So if I go back again to the top of my file, I can now start put these ones, and then let's load the dataset and then work on with Med 7. Perfect. And let's pick the next one, which is going to be my X. This is the value we are using, right? This particular one here. So I'll copy this, and then you use it to do our analysis to see if you're able to detect the same entities we had when we were using SciSpacy. So to work with Med 7, it's very simple. So we're going to load the package. So load package, it's going to be import Spacy, right? And then now we can just call it as Med 7. So this is going to be Spacy.load. Now passing my Med 7 stuff. So let me load this one. Let's call this one as X, right? S1. So we are going to must pass in the label or the name of the model that we downloaded from this, which is this particular name here. And as we did earlier on, it was underscore underscore, so you have to make sure that this underscore underscore, which is the same name, so that we don't get an error again. So I'll copy this, which is the name of the model for Med7, and I'll pass it here. Right, so now you can call it as Med7 NLP, right? And if I run it, now we're going to get it initialized, and then we can now do the same thing we did previously. Perfect, so that's finished. Now let's see if you can be able to use Med7 to extract and identify all the various entities there. So before we do that, let's check for the various components of this. So let's check for the component. So it's going to be Med7, as we did, NLP.components names. I go with component names, it's going to list the component name. So Med7 is very little, right? Just have the tokenizer and then the NER, not like SciSpacy, which is having several different components. And if in case I want to check for the various labels there, so it's going to be Med7 NLP.getPipe, as we did earlier on, and we're going to get the particular pipe. So getPipe, passing the particular component NER dot labels. So we want to see the various labels there. So to see the various entities there we have, I think it's going to give us, wow, a lot. So although Med7 is having just 2 components, but it has a lot of labels, so we can just check for the dosage of the drug, right? You can check for the drug itself, duration, form, frequency, route, and strength, which is quite good. But if you're using Spark NLP or Spark NLU for the clinical version, it has a lot of entities there. It has dosage, drug, duration, negation, procedure. It has a lot, right? So let's see if we can be able to identify some of them. So I'm just going to pass in the same thing. So let's go to my docs2. So Med7 NLP, I pass in my S, which is referring to this particular value here. So S1. So you run it, and now we can now visualize it. So let's visualize it. Instead of extracting them out, I'm going to visualize the entities there. So from Spacy, import Spacy, and now we can now visualize it. So Spacy.render, I pass in my docs 2. I'll specify the style I want, which is ENT, and then I'll specify that I want to use Jupyter. So Jupyter is set to true. So now it's going to extract all the entities and visualize it for us, right? Perfect. And as you can see, it was able to identify not most of them. Well, it was able to identify penicillin, right? Unlike the one we did, we didn't identify penicillin. So penicillin is a drug. I don't know why miscellaneous is a drug, funny. But it could not identify some of the diseases. Most of these diseases could not identify all of these things. It could not identify them, but it was able to identify penicillin as a drug. Let's try another example. So you have seen how to use Med7 and then Spacy and then SciSpacy to be able to extract or do named entity recognition of clinical tests. So in case you have any question or contribution, you can put inside the comment section below. We can use this one to do a lot of things. There are a lot of cool stuff you can do with this particular package, but this is some of them, right? Because with the Med7 you can see that we can extract a lot of things. So if I had the procedure and everything well structured, I will be able to get most of them. So let me do this way. Let's see whether I should be able to identify them. To lower, let's see, lower. If it's able to work fine, we can just convert the entire stuff and let's see whether it will be able to work. I'm converting everything to lowercase. I want to see whether I'll be able to trick it to determine some of them. You see that now it was able to identify only the penicillin, but this one they couldn't. Oh, cool, interesting. Okay, so thank you for watching this tutorial. See you another time, and check the links below for some interesting materials to help you master machine learning and then Python. I also have some courses on Udemy, so in case you want to benefit from these courses, you can also check it on Udemy and our website. See you another time. Stay blessed. Bye.